Assalamu alaikum students. Once again, I welcome you all to my YouTube video class. In today's session, we are going to discuss about a new chapter, that is iteration and recursion. In the previous chapter, we have discussed about what is algorithm, what are the building blocks of algorithm, and what are the different techniques we have used in the algorithm. Now, in this chapter, we are going to learn about variants and invariants and how to use iteration and recursion in the algorithm. There are several problems which can be solved by doing the same action repeatedly. Both iteration and recursion are algorithm design techniques to execute the same action repeatedly. So, in the last chapter itself, we have learnt about the iteration. What do you mean by iteration? Repeating the same set of statements again and again is called as the iteration here. So, why do you use that? In some situation, we need to repeat the same set of statements for certain number of times. So, for that purpose, we will use the iteration concept here. Even though the action is the same, the state in which the action is executed is not the same. So, each time we execute the action, the state changes. So, the same action is repeated for certain number of times, but the state will not be the same. The state will keep on change the value. Therefore, the same action is repeatedly executed but in different states. The state changes in such a way that the process progresses to achieve the desired input-output relation. So, when the state will change the value only, you will get the desired input-output relation. Now, we are going to learn about iteration. In iteration, the loop body is repeatedly executed as long as the loop condition is true. So, in iteration, we have a condition. When the condition is true, the loop body will execute. How long the loop body will execute? Till the condition is true. Okay. So, each time the loop body is executed, the variables are updated. So, we will use some variables in loop body. For each time we will execute the same statement, automatically the value of the variable will be changed. However, there is also a property of the variables which remains unchanged by the execution of the loop body. This unchanging property is called the loop invariant. So, what is meant by variant? Variant means keep on changing the value. It's called variant. Then loop invariant means there is also a property of a variable which remains unchanged by the execution of the loop body. This unchanging property is called the loop invariant. So, loop invariant is the key to construct and to reason about iterative algorithms. Next one is recursion. Recursion is another algorithmic design techniques closely related to iteration but more powerful. So, it is also process the same set of statements by repeating the action, but it using only the some part of the input. So, it never takes full input. It just takes only the part of the input value. With that, it performs the value and finally it produces the solution to the original problem from the solution to the partial input. So, using recursion, we solve a problem with a given input by solving the same problem with a part of the input and constructing a solution to the original problem from the solution to the partial input. This is called recursion. Now, let's see the example of invariance. What do you mean by invariant? Even the value of variable changes, also the property of the variable will not be changed. That is called as the invariant. So, the variable which remains unchanged by the execution of the loop body, this unchanging property is called the loop invariant. Example, consider the assignment is executed with u, v is equal to 20, 15. Here, we have two variables, that is u, v. The value of u is 20 and v is 15. We can annotate before and after the assignment. Hyphen hyphen before colon u, v is equal to 20, 15. I already told that the meaning of hyphen hyphen is comment line. So, before processing, the value of u is 20 and v is 15. This is the initial assignment. Next, we are going to perform some assignment, that is u, v colon is equal to u plus 5, v minus 5. Here, before assigning the value of u is 20 and v is 15. Here, u, v is equal to u plus 5 and v minus 5. So, the value of u is 20. So, 20 plus 5 is 25. Now, the value of u is 25. Then, the value of v is 15. So, 15 minus 5 is equal to 10 here. So, before the assignment, the value of u is 20 and the value of v is 15. Now, after the assignment, the value of u is 25 and v is 10. Do you understand this? So, the third line, hyphen hyphen after colon u, v is equal to 25, 10. Now, what do you observe about the value of the function u plus v? Here, we have to prove the invariant. Let's see that. Before u plus v is equal to 20 plus 15, that is 35. After u plus v is equal to 25 plus 10, that is 35. So, before the assignment, the sum of the addition of u plus v is 20 plus 15, the value is 35. After the assignment, the sum of, that is the addition of u plus v is 25 plus 10, that is 35. So, which is invariant here? U plus v. The property u plus v is not changed. So, u plus v is an invariant of the assignment. Then, we can annotate before and after the assignment with the invariant expression. So, before the assignment, u plus v is equal to 35. Then, during the assignment, we will change the value of u and v. So, u and v is equal to u plus 5, v minus 5. U value is 20, so 20 plus 5 is 25. V value is 15, so 15 minus 5 is 10. Then, after the assignment, u plus v is equal to 35. Now, u value is 25 and v value is 10. So, 25 plus 10 is equal to 35. So, u plus v is an invariant, because the value of u plus v is equal to 35 is not changed before the assignment and after the assignment. Do you understand the concept of invariant now? Now, let's see another example. If we execute the following assignment with p, c is equal to 10, 9. After the assignment, p, c is equal to 11, 10. So, after the assignment, p value becomes 11 and c value becomes 10. Before the assignment, the value of p is 10 and c is 9. And after the assignment, the value of p is 11 and c is 10. Now, we will start write the specification here. Hyphen hyphen before colon p, c is equal to 10, 9. Then p, c colon is equal to p plus 1 and c plus 1. Here, p value will be added by 1. The same way, c value will be added by 1. So, already we know the value of p, that is 10. So, 10 plus 1 is equal to 11. The same way, we know the value of c, that is 9. So, 9 plus 1 is equal to 10. After the assignment, the value of p is 11 and c is 10. So, what is happening here? Before the assignment, the value of p and c is 10 and 9, and after the assignment, the value of p and c is 11, 10. Then, can you discover an invariant? What is the value of P minus C before and after? We have to find whether P minus C is an invariant or not. So, before the assignment, P minus C is equal to 10 minus 9 because P value is 10 and C value is 9. So, 10 minus 9 is equal to 1. Then, after the assignment, P minus C is equal to, after the assignment, what is the value of P? 11 and C is 10. So, 11 minus 10 is equal to 1. Here, we find that P minus C is equal to 1 is an invariant. Because the value P minus C is equal to 1 is not changed before and after the assignment. So, P minus C is an invariant. Now, let's see another example. Show that P minus C is an invariant of the assignment. So, we have to show that why P minus C is an invariant. Okay, P comma C is equal to P plus 1, C plus 1. Here, we are assigning P value is P plus 1 and C value is C plus 1. So, while assigning P and C, we are going to prove that P is an expression. P of P comma C is equal to P minus C. Here, P minus C is an invariant of the assignment. Let P of P comma C is equal to P minus C. Then, P of P comma C, that is, P comma C is equal to P plus 1 comma C plus 1. Here, P value is replaced as P plus 1 and C value is replaced as C plus 1. Now, we are going to substitute the value. P minus C of P comma C is equal to P plus 1, C plus 1. How do you substitute the value? We already know that P value is P plus 1 and C value is C plus 1. So, P minus C means P plus 1 minus of C plus 1. Once, when we remove the bracket, what will happen? Plus 1 and minus 1 will be cancelled. Then, we will get P minus C. So, obviously, P minus C is what? P of P comma C. Do you understand that? Here, we proved that P of P comma C is equal to P minus C. So, P minus C is an invariant of the assignment. Let's see another example. Consider two variables m and n under the assignment. M comma n is equal to m plus 3 comma n minus 1. Here, the assignment of m is m plus 3 and the assignment of n is n minus 1. Now, we are going to prove that m plus 3n is an invariant. Now, we are going to write the expression. Let P of m comma n is equal to m plus 3n. Why I have written m plus 3n here? Because we are going to prove that m plus 3n is an invariant. Then, we have to write the assignment P of m comma n. M comma n is equal to m plus 3 comma n minus 1. Now, we are going to substitute that. Okay, the value of m is m plus 3 and the value of n is n minus 1. So, P of m comma n is equal to what? That is m plus 3n. So, we have to write m plus 3n of m comma n is equal to m plus 3 comma n minus 1. Now, we are going to substitute here. What is the value of m? M plus 3. And what is the value of n? N minus 1. So, m plus 3 plus 3n. 3. We have to write 3 as such and the n value is n minus 1. Do you understand this? Then, once we remove the bracket, what will happen automatically? M plus 3 plus 3n minus 3. Okay, here plus 3 and minus 3 will be cancelled. So, what will be the answer now? M plus 3n. So, we conclude that m plus 3n is what? P of m comma n. So, m plus 3n is an invariant. So, invariant means what? After assigning the value also, the property will not be changed. Do you understand the concept here? Now, we will move on to the next topic, that is loop invariant. In a loop, if L is an invariant of the loop, body B, then L is known as a loop invariant. So, invariant will not be changed after the execution of the iteration also. So, there are some rules or some points we have to keep it in our mind while we create a loop invariant. While C, here C is a condition, hyphen hyphen L, L is the start of the loop, B is the body of the loop, then hyphen hyphen L, here L is the end of the loop. If L is a loop variant, then we have to follow 4 steps. If it is satisfied all this, then that will be called as loop invariant. So, while doing iteration, automatically the value of the variable will be updated. That is, the value of the variable will be changed, but the property will not be changed. It remains the same. Then that is called as loop invariant. In which are the places it should satisfy the condition? At the start of the loop. Before we start a loop, property should be the same, and the same property should be maintained in all the 4 steps. Then at the start of each iteration, that is before the loop body, the property should be the same. Then at the end of each iteration, after the loop body also, it should maintain the property. Then at the end of the loop, just after the loop also, it should maintain the same property. So, in all the 4 cases, if it is satisfied, then only it is called as loop invariant. So, what is loop invariant? Loop invariant is nothing but after doing the iteration also, the value might be updated, but the property remains constant. That is called as the loop invariant. Let's take L as a loop invariant so that the start of the loop L is a loop invariant. Then while C, here C is a condition and B is the body of the loop. Then before the body of the loop also L is a invariant, and at the end of the iteration also L is a invariant, and after executing the loop at the end of the loop also it should be the invariant. So there are 4 points, 4 important points should be keep it in our mind while creating a loop invariant. Okay, let's see the flow chart. So which are the 4 places to maintain the same property? At the start of the loop, at the start of the iteration, at the end of the iteration, and at the end of the loop. So these are the 4 points where the loop invariant is true. Then how to construct the loop? Establish the loop invariant at the start of the loop. So we have to establish the loop invariant at the starting of the loop. Then the loop body should so update the variables as to progress towards the end and maintain the loop invariant at the same time. So while executing each time, the value of the variable will be changed, that is updated, but it maintain the loop invariant at the same time. Then only we will achieve the desired output. Then when the loop ends, the termination condition and the loop invariant should establishes the input-output relation. So at the end of the loop, what will happen? The condition made false. So it terminates the condition and it maintains the loop invariant. So that loop invariant gives the desired input-output relation. So this is all about loop invariant. Let's see the example of loop invariant now. The loop invariant is true in 4 crucial points in a loop. At the start of the loop, at the start of each iteration, at the end of each iteration, and at the end of loop. So, the loop invariant should be true in the above 4 points. Then only we will get a desired output. Example: design an iterative algorithm to compute a power n. That is, we are going to find the power of some particular value here. For example, power of 10, 4. That is, 10 to the power of 4 is equal to 10,000. How do you get 10,000 here? We have to multiply 10 by 4 times, that is 10 into 10 into 10 into 10, 10,000. So similarly, power of 5 comma 3 is equal to 125. So we have to multiply 5 by 3 times, that is 5 into 5 into 5 is equal to 125. Similarly, power of 2 comma 5 is equal to 32. We have to multiply 2 by 5 times, that is 2 into 2 into 2 into 2 into 2. The answer is 32. So to achieve this, we have to do the iteration process, that is repeating process. For that, we have to use a loop concept. Then we have to maintain loop invariant also. Then only we will get a desired output. Let's see now. Algorithm power of a comma n computes a power n by multiplying a cumulatively n times. So, based on the power, we have to multiply that many times the particular number here. Now, let's see the specification. Power of a comma n. Here, power is the name of the algorithm and a comma n are the two variables. Here, n should be the positive value. Then, the input property is n is a positive integer. Then, the output property is p is equal to e power n. For example, if I give 2 to the power of 5, then I should get 32 be the output value. So, for this, we have to write the algorithm. Initially, we are taking two values p and I. So, p variable is used for power and I variable is used for iteration. So, initially I am storing p value as 1 and I value as 0. Then, how many times the loop will repeat? Till I is not equal to n. So, till that the process will repeat. Then, the loop invariant is p is equal to a power I. So, before iteration also, the property p is equal to a power I should be true. Then after the end of the iteration also, the property p is equal to a power I should be true. Now we will see what is happening here. So at the beginning of the iteration, that is the first iteration, the value is 0, p value as 1, I value as 0 and a value as 2. Then what is the value of a power I? A value as 2, I value as 0, so 2 power 0. So anything power 0 is equal to 1. So 2 power 0 is equal to 1. Here the property is true. P value as 1, a power I value as 1. So 1 is equal to 1. The condition is true here. That is, the loop invariant is true. So before iteration, the loop invariant is true here. Then after that, iteration 1, that is next iteration. Look at the algorithm. P comma I is equal to p into a comma I plus 1. Here p value will be multiplied by a and I value will be incremented by 1. Here the p value is 1 and a value is 2. So 1 into 2 is equal to 2. Then I value is 0. So 0 plus 1 is equal to 1. Then a power I. A value is 2 and I value is 1. So 2 power 1 is 2. Then we have to check the loop invariant. P is equal to a power I. Here p value is 2 and a power I value is, that is 2 power 1 is 2. So both values are same here. 2 is equal to 2. Then the loop invariant is true. Then the next iteration 2. Now p value is 2. Then p into a. P value is 2, a value is 2. So 2 into 2 is 4. Now p value is 4. Similarly, I value is 1. So 1 plus 1 is equal to 2. Now I value is 2. Then a power I. A value is 2 and I value is 2. So 2 power 2 is 4 here. Then we have to check the loop invariant. P value is 4, a power I value is 2 power 2, that is 4. So 4 is equal to 4. Here the loop invariant is true. Then the next iteration 3. P value is 4 and p into a, that is p value is 4, a value is 2. So 4 into 2, 8. P value is 8 now. Then I value is 2, so 2 plus 1, now I value is 3. Then a power I. A value is 2, I value is 3, so 2 power 3, 2 into 2 into 2 is 8. Now we have to check p is equal to a power I. Yes, p value is 8, a power I value is also 8, so the loop invariant is true. Then the next iteration 4. Now p value is 8, then a value is 2, so 8 into 2 is 16. At present p value is 16. Then I value is 3, then 3 plus 1 is 4. At present the I value is 4. Next we have to check a power I. A value is 2 and I value is 4, so 2 to the power of 4, 2 into 2 into 2 into 2. Then the value of 2 to the power of 4 is 16 here. Then we have to check the loop invariant. P is equal to a power I. P value is 16. Then a power I value is also 16. So the loop invariant is true. Then the next iteration 5. Now p value is 16. So p into a. So 16 into 2. 16 to is 32. Then I value is 4. Then we have to increment I value by 1. So 4 plus 1 is 5 here. Then a power I. A value is 2, I value is 5, so 2 to the power of 5. What is the value of 2 to the power of 5? 32. Now we have to check the loop invariant. P is equal to a power I. P value is 32 and a to the power of I value is 32. So 32 is equal to 32. Both values are same, so the loop invariant again true here. Did you notice that for each iteration, p value and a power I value are same? Then the condition will check while I is not equal to n. I value is 5 and n value is also 5. So 5 is not equal to 5 is false here. Now the condition is false, so the control will come out of the loop. Do you understand that? So p is equal to a power I is true at the start of the loop and remains true in each row. So p is equal to a power I is a loop invariant because the condition is true for all the 4 cases: at the start of the loop, at the start of each iteration, at the end of each iteration and the end of the loop. I hope you understood this example, right? Let us see another example. Recall the chocolate problem. In the 6th chapter itself, we have discussed this example. Do you remember that? How many cuts are needed to break the bar into its individual squares? Imagine you have a chocolate bar. Now you are going to divide a chocolate bar into number of pieces. At first, we have a single piece of chocolate bar. A cut is made by dividing a chocolate bar into 2 pieces. Again, we will make another cut. Likewise, several cuts has to be followed to make several pieces. So, while we are doing this, we will get an individual square. Here, the problem is how many cuts are needed to break the bar into its individual squares. Now, we will find the solution to this problem. Let us assume the number of pieces as p, number of cuts as c, and the number of individual squares as n. Now, we decided to model the problem by an assignment. P, c is equal to p plus 1, c plus 1. Whenever a cut is made, the number of cuts increases by 1 and the number of pieces also increases by 1. So, each time when you do this process, automatically the value of pieces also increased and the value of cuts also increased here. So, p, c is equal to p plus 1, c plus 1. Now, we start with 1 piece and 0 cuts. So, p is equal to 1 and c is equal to 0 at the initial stage. Here, initially we have 1 chocolate bar and no cut over here. So, p is equal to 1, that is number of pieces is equal to 1 and number of cuts is equal to 0. So, p is equal to 1 and c is equal to 0. Then, what is the final point we have to check over here? P minus c. Here P minus C is the invariant of the assignment. So we have to find out P minus C is the invariant of the assignment. Now let us assume P minus C is equal to K. Here K is a constant value. And the points in the algorithm where P minus C is equal to K is true. So P minus C is equal to K is the loop invariant. This should be true at 4 important points in the algorithm. At the start of the loop, at the start of each iteration, at the end of each iteration, and at the end of the loop. Here we have an algorithm where P minus C is equal to K is true. P comma C is equal to 1 comma 0. Initially the number of pieces P is equal to 1 and the number of cuts C is equal to 0. This process will continue till P is not equal to N. That is, the number of pieces is not equal to the number of individual squares. For example, you want to share this single piece of chocolate bar into 5 friends. Then what will you do? You have to cut this chocolate bar into 5 pieces. So the value of n is 5 here. Now let's check the condition. P minus C is equal to K. Here the P value is 1 and C value is 0. So 1 minus 0 is equal to 1. K means any constant value but it should not be 0. So 1 minus 0 is equal to 1. Here the condition gets true. Now the loop begins. While P is not equal to N, here the P value should not be equal to N. For example, if I need 5 pieces means here the value of N is 5. This process will continue till I get 5 pieces. Now the value of P is 1 and the value of N is 5. So 1 is not equal to 5. Yes, the condition is true. Then the next statement, P minus C is equal to K. Before the loop also P minus C is equal to K should be true. Then the P value is 1 and C value is 0. So 1 minus 0 is equal to 1. Then after the loop also I have to check P minus C is equal to K. Yes, here also the same value 1 minus 0 is equal to 1. Now I am going to start the process. That is, I am going to cut a chocolate bar into 2 pieces. So, P comma C is equal to P plus 1, C plus 1. So, the number of pieces increases by 1 and also the number of cuts increases by 1. So, already the P value is 1. So, 1 plus 1 is equal to 2. Then C value is 0. So, 0 plus 1 is equal to 1. Now, the P value is 2 and C value is 1. Then again I have to check the condition P minus C is equal to K. Now P value is 2 and C value is 1. So 2 minus 1 is equal to 1. Yes, the condition is true here. So the same process will be repeated till the condition made false. When it becomes false, while P is not equal to N, that is 5 is not equal to 5. Now the control will jump out of the loop. Again the loop invariant is checked here. P minus C is equal to K. So at last P value is 5 and the number of cut is 4. So 5 minus 4 is equal to 1. Yes, the condition is true. Then P is equal to N. Now the number of pieces is 5 and the number of individual square is also 5. So this process will continue till the number of pieces is equal to number of individual squares. That is P is equal to N. Here the loop invariants are true in all the 4 cases. That is, at the start of the loop, at the start of each iteration, at the end of each iteration, and the end of the loop. Do you understand this? Now let's see the next example. There are 6 equally spaced trees and 6 sparrows sitting on these trees. 1 sparrow on each tree. If a sparrow flies from one tree to another, then at the same time another sparrow flies from its tree to some other tree, the same distance away but in the opposite direction. So totally how many trees are there? 6 trees are there. So in each tree 1 sparrow is sitting. Then, if a sparrow flies from one tree to another, at the same time another sparrow also flies from one tree to another but in the opposite direction. Now the problem is it possible for all the sparrows together on one tree? Actually, there is no possibility here. Let's find out that. Let us index the trees from 1 to 6. Totally we have 6 trees. So we have to give the index value to each tree. So the index of a sparrow is the index of the tree it is currently sitting on. Okay. Then a pair of sparrows flying can be modeled as an iterative step of a loop. When a sparrow at tree I flies through tree I plus D. So, a sparrow flies from one tree to another tree can be named as I plus D. Then, another sparrow at tree J flies through tree G minus D. Simultaneously, the another sparrow flies from one tree to another tree but in the opposite directions can be called as J minus D. Then the sum S of the indices of the sparrow should be invariant. S is nothing but sum of indices. We have totally 6 trees. So we have given the index value for all the 6 trees, right? That is S is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6. Totally we have 6 trees. If we sum this, we will get 21. So S is equal to 21. So, S is equal to 21 is the loop invariant. Moreover, a loop invariant is true at the start and at the end of the loop. So, at the start of the loop, the value of the invariant is S is equal to 21. When the loop ends, the loop invariant has the same value. However, when the loop ends, if all the sparrows were on the same tree, S is equal to 21. Loop invariant at the start of the loop. So initially S is equal to 21 at the beginning of the loop. Now we are going to find out whether S is equal to 21 is satisfied for all the cases or not. Then S is equal to 6k. Loop invariant at the end of the loop. So if it is true, that is S is equal to 6k is true, then all the sparrows can gather on one tree. Then 6k is equal to 21. Loop invariant has the same value at the start and at the end. Here k should be the constant. So if I substitute 1 in k, 6 into 1 is 6. It is not 21. Then if I substitute 4 in k, then 6 into 4 is 24. That is not 21. So there is no possibility to reach 21 here because 21 is not a multiple of 6. So 6k is equal to 21 is not at all equal. Why it is not equal? Because 21 is not a multiple of 6. If I substitute any value in k, I will not get 21 here. So the condition is not satisfied here. So the desired final values of the sparrow indices is not possible with the loop invariant. Therefore, all the sparrows cannot gather on one tree. Students, the first part of this lesson ends here. I hope you understood this. And the assignment of this lesson is: what is an invariant? Define a loop invariant. Does testing the loop condition affect the loop invariant? Why? What is the relationship between loop invariant, loop condition and the input-output recursively? Students, submit your assignment on time. Thank you for watching this video. We will see you in the next video class. Assalamu alaikum.